Good day, people. Welcome to another podcast with Martin Barna. Today, I have a very, very special guest. It is Dr. Gabrielle Fundaro. Hello. Thank you very much for accepting my invitation.
Oh my gosh, it's a pleasure. Thank you so much for inviting me.
I think everyone here knows who you are, but let's just say in a bit short sentence. Gabrielle Dr. Fundaro is a gut health specialist. She's a scientist with the specialization on gut health and microbiome, if I'm not mistaken. Mm-hmm. And also she's a coach, online coach, with specialization on habits, if I'm not mistaken, and healthy lifestyle in general.
Mm-hmm. Yeah.
Did I miss something?
No, that's great. So if anyone's unfamiliar, so I have my background in initially exercise science for my bachelor's, and then my PhD was in human metabolism and the gut microbiome. So kind of looking at the relationship between how the microbes in our gut might influence our metabolism, specifically in skeletal muscle. And after I finished my doctorate, I went on to teach for 4 years. And so I taught exercise science, anatomy and physiology, and sport nutrition. And in my 4th year of teaching, I was recruited by Renaissance Periodization. So I was an RP coach for 4 years and concurrently started my own business, Vitamin PhD Nutrition Telehealth. And I have recently gone to running my business 100%. So I have shifted from RP coaching to running my telehealth business, so I can give all of my attention to the folks who are working on establishing more satisfying relationship with food. And I am also presenting regularly on the gut microbiome and guiding people toward more comfortable digestion. And the book of gut health science for Renaissance Periodization that I've authored with Dr. Jesse Hoffman is in editing currently. So
I can't wait for this book. This will be great. Okay. Well, how did your interest in gut health started? Why did you, focus on this exactly?
Well, when I started my doctorate, I was actually studying the effects of high-fat feeding and obesity on skeletal muscle hypertrophy. And I had a side project that was examining the potential influence of probiotics on high-fat feeding and metabolic dysregulation. And it was sort of a series of accidents that we lost the samples of my main project. And so I had to make that side project on probiotics my main project. And the reason that I became interested in it was that we were treating mice and skeletal muscle cells and sometimes people with something called LPS, or lipopolysaccharide. So that's an endotoxin that comes from some bacteria in the gut. And when it binds to certain receptors of our immune system, it causes a low level of inflammation that's been associated with insulin resistance and incomplete fat oxidation and type 2 diabetes. And so I was curious about how we might get to the root cause. So I was initially wondering, why are we injecting with LPS? What is that supposed to represent? And then I learned that it is representative of a state that we see in individuals with obesity or type 2 diabetes, or even a person in a normative body size who has had a really high fat meal, that will see really high levels of this LPS in their blood. And so that's what we were representing with some of our studies. And so I became interested in getting to, like I said, kind of the root cause, looking at how the microbiome could potentially be modified in some way and what role it played in development of type 2 diabetes. And I didn't actually do anything with that after I finished my doctorate. I wanted to teach. And so I was offered an assistant professor position before I actually defended, which is really rare and an amazing opportunity. So I jumped on that. And when I decided to resign from academia and go into coaching full time, Mike Israetel from Renaissance Periodization was a really helpful sort of mentor to me. And he recommended speaking about the gut microbiome and gut health on a podcast with Steve Hall. So that was my first podcast on Revive Stronger. And from there, the podcast invites picked up. And then I started speaking internationally about gut health and the gut microbiome. And from there, it's just really been an awesome kind of snowball effect. And I've been really honored that people have provided me with a platform to speak about something that I didn't realize was going to be so helpful for so many people. Because when I finished in 2014, not a lot of people were talking about gut health yet.
Mm-hmm, mm-hmm. Now it's kind of trendy, I would say.
Oh, yeah.
And why did you start the coaching? You know, because you were a professor, you taught people. Well, it makes sense now a bit.
Well, the sort of the dynamic and the engagement and relationship that I was seeking in teaching came from my time in undergrad when I was tutoring. And I didn't tutor in a formal way. It was just that I really had a solid comprehension of anatomy and physiology, and I loved the course, and I just have a passion for learning. And so I think my peers saw that and thought that I really knew, kind of what I was doing and what I was talking about. And so they would ask for help. And eventually groups got together and would ask me to come and tutor them in like the library or in a classroom. And I absolutely fell in love with teaching at that point. But I think what I didn't realize is that what I really was being fulfilled by was helping them and helping them feel capable and empowered. And so that was my junior year of undergrad. And that's when I decided that I want to be a professor. So I went straight from bachelor's to PhD and then started my professorship quite young. And I think even though I had done a teaching fellowship and a professoriate certificate, I wasn't aware of sort of the differences in climate and culture between various institutions. So I ended up at an institution that wasn't probably like the best fit for me and the type of dynamic that I wanted to have with my students. And over time, I started to feel less fulfilled by that and more fulfilled by speaking engagements and my really small social media presence, where I had a blog and a Facebook page. And sometimes I would have a one-on-one conversation with a person and it helped them so much. And I thought, that's really what it's about for me. And actually, Mike Israetel was the one who found me. He found me in the ISSN Facebook group, having a collegial debate. And then he invited me for an interview with him and Nick, the CEO of RP. And then they recruited me as a coach and actually did that for part-time for the last year that I was teaching. Mm-hmm. And I just found it amazingly fulfilling and enjoyable and challenging. And I realized after that year that I would have to make a decision because I had also within that year started my own telehealth business. So I was literally working 7 days a week. And I thought, okay, this isn't sustainable. And I was going to have to make a decision, either focus on my academic career and go up for promotion or resign and go to coaching full time. And that's what I did. And my coaching approach has really changed and evolved over the last four years. And it's been really incredible. It was a scary decision, but I would absolutely do it again.
Yeah, I think it was a very good decision. Okay, I would like to start a topic of microbiome, if you don't mind. Look, there are many myths about microbiome. Which are the worst you would like to explain to people, Mm-hmm. If there are some worst.
Yeah, I was gonna say, so I would say that the most harmful myths would be probably those that make people fearful of foods mm-hmm. and that are selling them a problem that they don't have mm-hmm. so that they'll buy a solution. Mm-hmm. So for example, sort of the myth of bad gut health and that bad gut health causes any sort of malady that we don't actually have a cause for, like headaches, fatigue, acne, difficulty losing weight, menstrual irregularities, you name it, people will say, oh, it's because of bad gut health. And that's harmful in two ways. For one thing, in the most significant way, it might prevent a person from actually getting a real diagnosis for an actual disease and not receiving treatment. The other thing is that it probably causes them to spend a lot of time and money that they didn't need to spend on things that don't work. So that brings me to the second one, which would be the myth of IgG food sensitivity testing. This is really
great topic.
Yeah, it's very common in sort of alternative medicine, functional medicine and naturopathic practices. And I'm sure that the practitioners have good intentions, but it is bad information because IgG food sensitivity tests do not actually measure a food sensitivity. Food sensitivity is not even really the most accurate term that we could use if someone has an intolerance or an allergy, but an IgG antibody, even though that test does measure those, that's true, the IgG antibodies are just a recognition and a tolerance antibody. So if we have a lot of IgG antibodies, it means that our immune system recognizes the proteins in that food as safe. And what happens is people will then remove so many of their habitual foods that they may end up with a very low calorie diet, nutrient deficiencies, a lot of fear and anxiety around food. And then they will never actually figure out, what the problem might have been. And it's also expensive. So, that's another one that's very prevalent and really problematic.
Doctor, just a second, please. So there is no way to find out what are you intolerant to, even from blood, from gastroenterologist or whatever.
Well, if
you can specify it, just
right, yeah.
It's a big topic here.
Oh, absolutely, yeah. So there are two different terms. There's a food intolerance. So an intolerance is due to the lack of a digestive enzyme that's needed to break down that food. In some cases, humans just don't make the digestive enzymes, and that's why we can't break down fibers, for example. In other cases, some people make the enzyme, like lactase, and others don't. And so they would be lactose intolerant. So an intolerance is not life-threatening. It just causes GI distress, which is it can be uncomfortable, gas and bloating and things like that. And that is due to, again, just the lack of an enzyme. So we're not fully breaking down the macronutrients in that food. A food allergy, on the other hand, is mediated by the immune system. So that means our immune system has identified accidentally a protein in that food as being an invader, like a pathogen. And it mounts a really big immune response to that food. So there are two different types of food allergies. We can have an IgE-mediated food allergy. Now we can screen for IgE-mediated food allergies if a person has a history of an allergic response, like they're getting hives after eating, then an allergist or immunologist could screen them through various methods, maybe a skin prick test, but that's not a diagnostic test. And there are also non-IgE mediated food allergies, which might manifest as immediate vomiting. And there's really not a way to screen for that. So an allergist or an immunologist might do something like an oral tolerance test, where they'll have a person have a very, very tiny, a minuscule amount of the food that could be an allergen, and then see if there's a response, tingling or swelling of the lips. But that is, and that's probably what could be considered the most accurate sort of diagnostic test. But that's something that would need to be done by an allergist or an immunologist, because allergies can actually be life-threatening. So if a person has a serious allergy to something like peanuts or shellfish, for example, and they go into an anaphylactic shock, that means that they have such severe swelling of their airways, of their throat, that they may not be able to breathe. It can cause changes in their heart rhythm. So allergies are really serious. And so those need to really be monitored, and we need to be careful about that. Whereas a food intolerance will just really cause some GI distress. Now, people use the term food sensitivity sometimes to refer to either one of those. And sometimes they're using the word food sensitivity as a marketing term just to sell those food sensitivity tests that are the IgG antibody tests. And in that case, it's really just a made up term. And we may accidentally or kind of coincidentally remove a food that we're intolerant to based on the results of our IgG test. But that's just a happy accident. That doesn't mean that the IgG test actually identified anything for us. It's just that we happen to remove something that we were eating all the time that we're intolerant to. And quite often people are eating things like apples, garlic, onion, avocado, and those are foods that are high in something called FODMAP. So those are fermentable carbohydrates, and those will often cause some GI distress. So if you're eating those types of foods very often, or even apples, you might be really surprised to know that they could be causing you to have some gas and bloating. They're not unhealthy. They're not damaging you. It's just that the chemical structure of those carbohydrates makes them very easy to ferment by the bacteria in our guts. And the bacteria are really happy about that. That's what they're using for energy. And we just kind of have to deal with the byproducts being gas in some cases.
So just to make things clear for everyone, you cannot go to blood test to your guru and he cannot tell you you are allergic or intolerant on caffeine, etc. It is BS, right? Okay, I just wanted you to say it. Thank you very much. Okay, you can continue if there are any other myths you wanted to say. I just interrupted you. I'm sorry.
Oh, no, totally fine. I think that the other big myth would be that the gut microbiome is a cause of anything. So we haven't actually established any causative links between the microbiome and any form of disease. So to give people an idea of why it's so challenging to do that, I think we kind of think about the bacteria or the microorganisms in our gut as like a small group of bacteria or sort of like one organism all acting in unison. And so then we would be able to say, okay, we can establish cause and effect because we can change the microbiome and then see some outcome. But that's not the case. So we have tens of trillions of microorganisms in our gastrointestinal tract. We have bacteria, archaea, fungi, including yeasts. We have bacteriophages. So these are viruses that infect bacteria. We have viruses. So a huge ecosystem exists in our GI tract. And each one of these organisms is acting independently, but also is collaborating with other organisms around it. And each group of organisms might be influencing another group. So they're competing for nutrients, for real estate. Some of them are using the byproducts of one group's metabolism as maybe an energy source. So you can think of this as sort of a whole, if we think of like the ecosystem of the ocean, or thinking of the ecosystem of a desert or a rainforest, it's incredibly complex. And when we try to say that the gut microbiome is the cause of anything else, it's like saying oceans, everything in the whole ocean is the cause of a tornado in Texas. It's just impossible to say that. Sure, there might be some relationship there between, oceans and precipitation and things like that, but it's far too complex. And so we haven't been able to establish a cause and effect relationship. All we can do are look for patterns and say, well, a lot of people with an inflammatory bowel disease seem to have more potential pathogens than people without an inflammatory bowel disease. That's as far as we can say. And that's from a fairly limited data set so far, because the other thing is we've only just recently really been able to look at who is there in the GI tract with a high level of resolution, with a high level of detail. So we can, for a long time, we've been able to look at the level of, that might be considered like comparing vertebrates to invertebrates on planet Earth. So you can imagine if an alien race came to planet Earth and their technology could only compare vertebrates to invertebrates, people like things with a spine versus things without a spine, they wouldn't get a lot of data about planet Earth, right? They still would be really confused. So only recently have we been able to get down to like the species level or even the strain level. So in just like the past couple of decades, the alien race can go from, okay, vertebrates versus invertebrates to being able to differentiate between dogs versus wolves. But because it's so expensive, in most cases, that's not really occurring. And so we're really only able to look at maybe the level of like all things that look like dogs versus things that don't look like dogs, like things that look like cats. But even, when we're comparing in that way, there's such a difference between like dogs versus wolves versus jackals and dingoes. So that's sort of us. We're that alien race kind of trying to, examine who's there and what they're doing. And we haven't yet been able to establish, okay, how does the activity of this one group of wolves influence the activity of this group of elk over here? We have not gotten to that point yet.
You are very good in explaining things. Is there any other myth that came to your mind, or can we continue?
I think that would be about it, because that really sums up a lot. It's sort of my take-home message is if someone is selling you a problem about the gut so that you'll buy their solution, just be a little bit wary of that. Not to say that there are no interventions to improve the health of our GI tract or to support a diverse gut microbiome or even to improve digestive comfort. There are interventions, but if someone is saying that you have bad gut health or you have dysbiosis or leaky gut and they have a treatment or a cure for any of those things, those are definitely red flags that person is using marketing terms to sell you something.
Look, I've heard that some people, they say that they are obese because of their gut health, let's say, that they say that they are very effective in a thermic effect of food, let's say, in general. Is it right or is it not true?
Well, that was a theory that started probably about 10 years ago. This idea of enterotypes. So if people are familiar with somatotypes, people used to think there was an ectomorph, mesomorph, or endomorph body type. And we used to sort of think that about the gut microbiome, again, looking at that level of vertebrates versus invertebrates. So we thought, well, if you have more vertebrates than invertebrates, if you have more Firmicutes versus Bacteroidetes, then that's an obesogenic enterotype. That means that you are more prone to have obesity in that case. But that was disproven pretty quickly, because when we get past that level of vertebrate versus invertebrate and we get down to the species and subspecies level, we find that, oh, wow, even within a single species, there can be different subspecies or strains that all behave really differently. And that even though there are some types of bacteria that can convert fiber, which is indigestible to us, to a short chain fatty acid, which is digestible, that wouldn't fully explain body weight. But it came from some landmark studies that were done in the early 2010s that were in rodent models. And this group took the gut microbiome from rodents that were genetically modified to develop obesity and transplanted those into lean mice that did not have a gut microbiome. And the lean mice developed obesity. And it was either through eating more, which makes sense, or in some cases, it was through increased energy harvesting. So it is true that our gut microbes can increase the energy availability of our diets for us. And studies have shown or estimated that might be up to about 200 calories per day, depending on the individual's.
That's quite a lot.
Gut. Yeah, exactly. So, right. So it gives us some awareness that there is obviously a margin of error when we're calculating our energy intake and kind of using that to regulate our body weight. So it may be that, we calculate that we need about 1,800 calories per day if we, want to lose weight and we're burning about 2,300. And so we calculate, we're eating 1,800 calories and we're kind of like, wow, this is weird. I should be losing a pound a week and I'm only losing about a half pound a week. Well, maybe we have a gut microbiome that is harvesting an additional 200 calories for us. But at the end of the day, it really comes down to, still realizing that everything that we do would be an estimation. And if over time we find that we are, trending at this half a pound a week thing, pace, then we eat the 200 calories less and say, oh, maybe it was my microbiome. I have no idea. And I have no way of changing that. So let's not worry about it too much. But it wouldn't be able to, like I said, fully explain sort of the differences in, individuals who may have a very similar body size, but, one has a greater propensity for weight gain, because there are things like, socioeconomic factors, physical activity, non-exercise activity. So we have to take all those into consideration. But yeah, keeping in mind that, there could be, a margin of error there of up to 200 calories per day.
Up to 200. So everyone can lose weight still.
Yeah.
And that was the point.
Right. Yes, exactly. And, that's just emerging data. And some people had no, in this, so it was, it's been only in a small handful of studies that they've really looked at that. And they've estimated based on intake, doubly labeled water, and then, calorie loss in stool. So that's how they, kind of calculated that. But yeah, some people had no increase in energy harvesting. So what they ate, went in, and that's what they got out of the diet, and that was it. So it might be that, that doesn't apply to you. And there's really no way to know. There is, we're not there yet.
Well, but if you self-monitor your info about you, you can still lose weight quite easily. It will just be different number, let's say, if you think in numbers. Yeah. Is there some definition of, let's say, good gut health, or a good, healthy microbiome, or something like that? Or is it very different in anyone?
Yeah, that's such a good question. So because I think a lot of people are concerned about that, and we hear so much about bad gut health, and we think that there probably is good gut health or a healthy gut. We don't yet have one profile of a healthy gut, because there are differences in the profiles of microbiomes based on region. So a healthy individual in the UK will have a profile that looks different from a healthy person in the US or Japan or Korea or the Ukraine, wherever. We really cluster by region. And then we also we cluster by age, and to some extent by gender. So each person's healthy microbiome is unique. It's like a fingerprint. We have about, we have a sort of a core microbiome. About 1/3 of our microbiome exists because or looks the way it does because we're humans. So there's a species specific core microbiome. And then the other 2/3 are more individual, and those might be explained by our gender, our age, our ethnicity, and our region, so wherever we're living. And within that, we may also see that there's an influence of our diet and our physical activity habits. So one person's healthy gut, is going to look different from another person's healthy gut. But there are some characteristics that we would consider to be associated with sort of what we might call good gut health. And I've kind of come up with a definition that I think is sort of all encompassing. So we're looking at diversity of the microbiome. So we have a large number of species. We have a relative proportion that is a little bit higher in the beneficial or neutral organisms and a little bit lower in those that could cause disease. So we're suppressing their ability to really cause disease. And then there's a high level of functional diversity as well. So we have many different genes. And that way, if one group suffers a loss because of a drug or something, that we still have maintained the functionality because there's a lot of redundance. So a lot of those organisms can do the same things. And so that makes an ecosystem that is stable over time because it's resilient. So it can bounce back quickly after some sort of a challenge. And then we also can look at disease. So within the gastrointestinal tract, if we're talking about health, we're probably saying that there is either an absence of disease or that if there is a disease, it's well managed. And we could be looking at an organic disease. So there's something wrong with the anatomy of the GI tract. or a functional disease where the anatomy looks normal, but it's not behaving kind of the way that it should.
Mm-hmm.
And then there's also the concept of digestion. So when people are thinking about gut health, they're also probably thinking about comfortable digestion. So it feels like I'm not extremely bloated or gassy. I have a regular number of comfortable bowel movements throughout the week, and that I feel, satisfied after my meals. So I think those three are that's kind of what I've called like the 3 Ds of gut health, are diversity, disease, and digestion.
Right, right. Look, this came to my mind. Artificial sweeteners. I've heard that they affect gut health, but also I've heard that anything you eat affects gut health. So is there some correlation, or let's say causation maybe, between artificial sweeteners and worse gut health?
Oh, there's a fun quote. I think it might have been from Food Science Babe. And she said, if you want to scare people into not buying something, tell them it affects the gut. If you want to convince people to buy something, tell them that it affects the gut.
Yeah.
So to some extent, yes, potentially anything that we consume and any form of activity probably has some influence on the gut. Or at least interacts with the microbiome in some way, especially anything that we're consuming, because it's going into our gastrointestinal tract. But that doesn't necessarily mean that it has an effect on the microbiome, that it actually causes any sort of meaningful change. Mm-hmm. And that's what we find with artificial sweeteners. Both the amount of data and the magnitude of effect are so much greater in a cell culture model than in humans. So we have a lot of data in cells and a fairly large amount of data in rodents. And it looks like they could have an effect in those models. Mm-hmm. But that's really due to the dose, sort of the relative dose that we can apply to cell culture or on a rodent model, which is much higher than what a human could reasonably consume or what is recommended for humans to consume. So when we look at the actual human data that look at the effects of artificial sweeteners on gastrointestinal hormones or the gut microbiome, so the actual microorganisms, we really find that there's across the board no effect. Mm-hmm. Because in part because the microbes will want to they'll want to they'll interact with things that they could potentially metabolize. So that's really the case when we're looking at like the interaction between the microbes and drugs, for example. In most cases, either the drugs are made to destroy bacteria, antibiotics, of course, will be in effect, or the drug contains some compound that the microbiota can metabolize in some way or interact with in some way. And that really doesn't seem to be the case with artificial sweeteners. There's just not anything in those compounds that are useful to the microorganisms, and they are fairly benign. And they're also ingested at really low levels. So for example, with sucralose, it's sold as Splenda, we are not ingesting pure sucralose when we are using the artificial sweetener like in packets. Mm-hmm. We're taking a tiny, tiny, tiny bit of sucralose and mostly maltodextrin, because sucralose is about 600 times sweeter than sugar. So if we tried to use sucralose on its own, we would have to have like 2 granules. It would be useless. We wouldn't actually be able to do anything with it in our kitchen. Mm-hmm. So that's the other thing, is that we're not taking in the doses that we're seeing in studies in cell culture and rodents. And so it's really important to look at human data and to also make sure that we're looking at human data with a control group. So something that's a randomized control trial or an RCT, because if we don't have a control group or we have a really small number of participants, this happened with, I think it was sucralose. They had 3 out of the 10 people seemed to have some response to the sucralose, but there was no control group. They took some fecal samples from these folks and put them into mice and did something that's called pseudo replication. So we can take the fecal sample from one human and put it into 5 mice, and then say that we have an N of 5 or like 5, participants in that group. That's not really accurate, because we've taken one person's fecal sample. Mm-hmm. And so it's really an N of 1. But that's something that is really common in gut microbiome literature and just hasn't been standardized yet.
Mm-hmm, mm-hmm. Do you think, is there any use of probiotics? Or,
Oh yeah.
and for what there is proven use and for what there is not proven use, please.
Yeah, yeah. So I'll do a shameless plug that I wrote or collaborated on an article with Precision Nutrition.
I know that's why I'm asking.
Yes, yeah. So it was a pretty extensive article on probiotics and their applications. So probiotics do have applications. It's just that they are pretty narrow at the moment, and that they are pretty specific as well. So there's not like one probiotic that we can just take to, you know, improve overall gut health. It's not like a multivitamin where we just take one every day, just, you know, for a little bit of extra insurance. The effects of probiotics appear to be pretty strain specific. So that means we have to get down to the subspecies or strain level. It's like the difference between a dog and a wolf, or a dog and a dingo. So if people are not familiar, like dingoes are wild canids, and they're not something that you would usually have as a family pet. Same thing with wolves. We can make a dog-wolf hybrid, but they're still, you know, probably a little bit more wild than like our domesticated beagle. Yeah. So that's the specificity of effect. And then also it looks like their greatest utility would be in GI distress specifically, and mostly with diarrhea or irritable bowel syndrome or inflammatory bowel disease. So they can help with some of the symptoms associated with like antibiotic diarrhea or traveler's diarrhea or those diseases. Outside of that scope, their effects are really minimal or non-existent, or the studies have been so different that we haven't been able to form a solid consensus statement. Mm-hmm. So one example with this would be with weight control and probiotic supplementation, that there's about a 1-to-1 ratio of studies that show an effect versus studies that don't. So we might see that there's a slight effect on waist circumference or BMI, but it's really minimal and it's not consistent across every study. So it's really difficult to say that, like, yes, probiotics work for weight management, or probiotics work for, you know, like the common cold, upper respiratory tract infections. Some emerging evidence suggests that might be the case, but again, it's so weak because it's so heterogeneous. There's no standardization for how much probiotic, how often we're taking it, and for how long.
Mm-hmm, mm-hmm. Do we have some evidence that walking or exercising affects gut health directly?
Mm-hmm. Mm-hmm. Yeah, most of the data, I would say almost all of the data really has looked at the relationship between endurance exercise or cardiovascular fitness and gut microbiome diversity, or profiles of the gut microbiome, like which taxa, which groups of microorganisms are most abundant. And so far, it's pretty firmly established that that diversity is positively correlated with cardiovascular fitness. So that means the more fit you are in terms of like aerobic exercise, endurance exercise, the greater your microbial diversity will likely be. And so that's regarded as a good thing. And that we also see increases in butyrate producers. And butyrate is a short chain fatty acid that's been associated with a lot of positive health outcomes and sort of metabolic health, like insulin sensitivity, for example. So that appears to be one way to support a diverse set of microorganisms, but it does appear to be mediated by exercise. And even in, it appears to be mediated by diet. So there was a really interesting study done in the past couple of years that looked actually at bodybuilders, and it compared, they were trying to determine whether probiotic supplementation would have an effect, and it really didn't. But what they found was that bodybuilders who were eating an inadequate amount of fiber, their microbial profiles were not any more diverse than sedentary people. Whereas the bodybuilders who were eating adequate fiber did see what we would sort of expect, that with increased exercise engagement, that there is an increase in microbial diversity. And there have been some other observational studies that have gotten at this as well. So in both cross-country runners and in bodybuilders who are eating an inadequate amount of fiber, sort of like the trade-off between fiber and fat or fiber and protein correlated with changes in diversity. So to say it more clearly, if we eat a lot of protein or a lot of fat at the expense of fiber, then we actually have lower diversity than what we would expect to see in people who are fit and exercising.
Interesting. Is there any way how we can positively affect gut health?
I would say that the easiest and most evidence-based ways would be to engage in regular cardiovascular activity. So if we can do some form of aerobic exercise, even to just meet the World Health Organization's recommendations, or, you know, the kind of like the old adage of like 30 minutes a day, about like 5 days a week. That would probably be a great way to start. It doesn't have to be super intense. It just has to be something that would be considered to be like challenging to your cardiovascular system. So, you know, 60% VO2 max or something like that, a little bit and above. That's probably a good range. If you're feeling like you're a little bit out of breath and you're working up a little bit of a sweat, start there a few times a week. If you're not doing any right now, you wouldn't want to try to go to 5 days a week. But if you can get some aerobic activity, that's a great idea. We don't really know the effects of resistance training yet, but we can probably guess that based on what we've seen so far, it's a good idea to do that too. And then also eating a diversity of plant-based foods. So it doesn't mean that you have to be vegan or vegetarian. There's actually, they have looked at that and they really haven't found that to be particularly advantageous compared to an omnivorous diet. But ensuring that you're eating a variety of fruits, vegetables, whole grains, and beans or legumes and nuts, then you are going to be good to go. So I usually recommend that people try to eat some form of plants at each meal, and getting, you know, 5 servings a day of fruits and vegetables. And a serving could be as easy as, even though there are real definitions for servings, but if you're just starting out, like a handful of vegetables or a handful of fruit at each meal, that's an awesome place to start.
Perfect. Do you think that this means that keto diet would not be optimal for people?
So this is an interesting question because they're looking more into effects of the ketogenic diet on the gut microbiome. So the ketogenic diet is one intervention for people with epilepsy. It was actually designed for children with epilepsy because it's associated with reduced seizure frequency. And then, you know, whole families would go on the ketogenic diet and people would lose a lot of weight and thought, oh, that's really interesting. And so the ketogenic diet became a weight loss diet over time. So the ketogenic diet does have a significant and repeatable effect on the gut microbiome. It's associated with reduced microbial diversity, losses in bifidobacteria. So that's one that's, we often hear about that. It's a probiotic type of microbe because it's very sensitive to reductions in fiber. And potentially a thinning of the protective mucus layer on the intestinal tract, because the microbes that really need carbohydrates will turn to that mucus layer to attain the carbohydrates they're not getting from our diet. And also 1-ketone body, beta hydroxybutyrate, appears to be suppressive again. So it actually suppresses the growth of bifidobacteria. So those could potentially be negative effects. But there is a potential positive effect in the regulation of specific immune cells called T helper cells. So there are some types of T cells that help to kind of regulate inflammation, for example. And so that could be one potential benefit, but we don't know whether the potential negatives outweigh the benefits. That being said, there's probably a reasonable and prudent way to engage in the ketogenic diet. So you want to ensure that you're getting adequate fiber, especially soluble fiber that you can get from some vegetables. So like you would actually want to eat the vegetables that are higher in FODMAPs, or those fermentable carbohydrates, and then some fruits and even some nuts. So it would be possible to eat a ketogenic diet and do so in a way that probably would not result in so much loss of diversity, because you're still providing them with enough fiber. But it would just take some planning, and it's not inherently going to be good for your gut.
So fiber is very important. We cannot say it is not needed.
Right, yes, yeah. Yes, yeah. So yeah, we call the other way to think about it is a microbe accessible carbohydrate. So it's a carbohydrate that is not digestible to us. So it passes through our small intestine and goes to our large intestine, where we have about 97% of our gut microbiome. And that's where that can be metabolized. So they actually use those as an energy source.
Mm-hmm. Is there any research on gut microbiome and Crohn or ulcerus?
Crohn's disease and like ulcerative colitis?
Yes, yeah. That's what I mean. Sorry.
Mm-hmm. Yep. So they have not established, again, any sort of causative link. So they can't tell whether, Crohn's or UC might cause changes to the microbiome, or it's the microbes that are sort of causing the disease. Mm-hmm. There's very likely kind of a cyclical relationship. So that some of the microbes may play a role in the disease progression, and then effects of the disease on the anatomy of the gut might then have an impact on the microbiome. And obviously there are going to be some changes in dietary intake as well. So that could influence the microbes. And the overall, again, when we can kind of look at the correlations or relationships, the individuals with Crohn's or colitis do tend to have a profile of microbes that look different from people without those diseases. But there's also such an individual variability that, again, it's really hard to say like, oh, we always see this one microbe or we never see this other microbe. But there tends to be either fewer beneficial organisms than we would expect to see, or more pathogens than we would expect to see compared to healthy controls.
Mm-hmm, mm-hmm. Thank you. That's very interesting. Okay, I also know that you love coaching. So a few questions about coaching. How would you define a great coach?
I think a great coach is a person who doesn't necessarily think they're great, but helps their clients believe that the client themselves is great. That's kind of what I say. Like, a good coach that, gets their client to say like, wow, you're such a good coach. And a great coach helps their client say like, wow, I'm so great. I did that.
That's great. That's just beautiful. Okay. And are there some things you think a good coach should do with every client? Some process you think is very necessary for any coach?
Mm-hmm. So Shannon and I, so my colleague and very, very dear friend, Shannon Beer and I, we started kind of writing about the industry and coaching about a year and a half ago, actually maybe more than that. And we were trying to operationalize sort of best practices in coaching based on best practices in a therapeutic alliance. So coaching and therapy are all obviously different, but there's a great deal of overlap in that we are trying to help people increase their capability, functionality, and self-efficacy, or their belief that they can do a thing. And what we found over the course of writing and continued education was that one of the deciding factors in outcomes for a client or a patient was the attitude of the practitioner, and that empathy is a really important trait for the practitioner to both practice, because it can be a skill, and embody and express. And empathy is the ability to, and I should say accurate empathy is the ability to express a deep understanding for another person's inner world, so that you can show that you know what they're experiencing in a situation. And that helps them feel understood and validated. And it's not that you have to agree with their behavior or think that, or agree with their beliefs or opinion, but that you can express that we as humans share in kind of the same spectrum of emotional experience. And so if a person says, oh man, I did this thing the other day and I'm so mad at myself, I can say, oh yeah, you're really disappointed. Like you really had expectations that weren't met, and you're feeling really down on yourself. You're kind of kicking yourself for that. And they're like, yeah, you know, and we don't have to tell them what to do. That the clients often already have really great ideas. And we instead, through a process of collaboration, we evoke that from them. And so we help them to strengthen their own commitments and their own motivation to make a change or to sometimes not make a change. And that we also ideally are practicing acceptance. So we're meeting people where they are. We're not telling them like this, you need to come to me, you need to do it my way. We're meeting them where they are, and we're asking them what next step they would feel comfortable taking.
Mm-hmm.
And that we're also conscientious and compassionate. And so we're conscientious in that we recognize that we have a responsibility to this person, and we're compassionate in that we want to either provide them with hope or reduce their suffering in some way. So I think when we embody that attitude, that's foundational to any skill that we might do, and that we can have a whole toolbox full of great skills and the most knowledge ever about nutrition. But if our attitude toward clients is derogatory, or we're belittling them or humiliating them or shaming them, that there's a very small chance that we'll actually be able to effectively utilize any of our tools or our knowledge to help them. Because change is, you know, when we're shaming people, when we're making them feel inadequate and less than and incapable, they're going to be very unlikely to feel ready to make a change.
Mm-hmm. Mm-hmm. It makes sense. I really love your psychological approach to a client, let's say, which reminds me of one thing I forgot to ask you. Do you know about any, let's say, connection between psychological problems, I mean, depression, for example, and gut health? Is there some research on that?
Yeah, so this is really interesting because there's a high level of concurrence between GI distress, and especially IBS, and mood disorders. So about 50% of people with IBS will also have a mood disorder, and vice versa. So there is certainly a relationship between those two. And in rodent models where we're able to we're able to rear mice without any microbes in their gut, like they're born sterile and they grow up sterile, that they actually have incomplete brain formation, and they fail to completely develop neurologically. And we can actually even induce some behavioral changes in mice with fecal transplants. But we really haven't seen the same thing play out in humans. So fecal transplants haven't been shown to really change behavior, and probiotics really haven't been shown to improve mood disorders. And probably just because the human nervous system is much more complex than the mouse nervous system, with all due respect to mice. When people say things about mice, about their mood, I really have to wonder, like, do mice have a mood though?
Yeah,
I mean, you know, do mice feel a sense of like ennui? Do they get bored? Maybe, but it's much more likely that even if they do, it would not be the same magnitude of human experience, you know, because we have these frontal lobes and everything like that. We have a sense of self and conscientiousness and sentience that rodents just don't really have. And any researcher will say a mouse model is not intended to be extrapolated to a human. It's mechanistic. It's just to say, oh, do we have like some proof of concept here that this could be a thing? And then we gradually move through more and more complex organisms, and maybe to like primates, and then to humans, you know, if it's something that's going to be like a really significant intervention. So definitely there's a relationship. There's also a nerve, the vagus nerve, that regulates about 75% of our parasympathetic nervous system. That's the rest and digest nervous system. And that actually appears to be a bidirectional, so it's a two-way street of communication between the gut and the brain. And we also have something called the enteric nervous system, which is a gut, sort of a gut-specific nervous system that operates without any assistance from our brain. It's really interesting, but it does also communicate with both branches of the autonomic, or sort of the automatic nervous system, so the parasympathetic and the sympathetic nervous system. So there's a relationship there. The microbes can communicate sort of through those nerves, or sort of indirectly by some of the postbiotics that they produce. But I think one myth here that I would bust would be the idea of gut-derived serotonin. So yeah, the majority of serotonin in the body is produced in the gut, but it's not the same serotonin that's produced in the brain that influences our mood. It's two separate pools. They're regulated by two different enzymes. And the gut-derived serotonin regulates gut motility or movement and fat and glucose use while we're fasting. But that does not cross the blood-brain barrier. So it's very unlikely that it would have a direct effect on our mood. So when people say things like, oh, happy gut, happy mood, not really.
Look, I know your time is limited, so two more questions. Okay, first question. If someone wants to hire you, how can he do that? Or she, of course.
Oh, yeah. Well, that I would be honored. And I would recommend checking out my website. So that's vitaminphdnutrition.com or my Instagram, vitaminphd. Then they can kind of get a sense of my approach. And I have all of my comprehensive coaching lifestyle plans linked there, as well as my gut health guidance and consultations. So they can check all of that out at vitaminphdnutrition.com.
A very interesting topic. Today, I really love this talk, I have to say. So last thing, if you could give just only one tip to anyone, what would it be? Anything.
I would say try to be, if it's not a gut health tip, but I would say kind of like a take home everyday thing. Try to be compassionate to yourself.
That's perfect. That's really perfect. Okay. Is there anything you would like to say? If I missed something you would like to say today?
No, just that I really appreciate this talk and your invitation, and I hope that this helps people. And if people have questions, I have a lot of free content on my Instagram page. And if people want to hear more about coaching, Shannon and I are actually starting our second annual comprehensive coaching webinar series Thursday, April 8th. And that is going to be running every week for 3 weeks. If folks can't tune into the live webinars because they've missed the ticket sales, they can still purchase the recordings. And if you have tickets or a recording, then you'd be eligible to attend one of our small group practical application sessions. So those are really intimate groups of 10 people or fewer. And we call in and have a whole video chat. We talk about some real life applications of the coaching framework that we've developed and take tons of questions. People can also check out btgcomprehensivecoaching.com and can also subscribe for a membership to our Facebook group. We have close to 60 members now, and we actually invite both coaches and clients to join and just have conversations about some of the tough topics in the industry and, try to make some positive change.
This sounds really interesting. Okay, I recommend this to anyone. Just check out, at least check out Vitamin PhD Instagram. Very good content. Okay, thank you very much, Dr. Fundaro, for your time. I am really appreciate it, and just have a nice day. And I wish you only the best in your coaching career.
Thank you so much. Thank you. The feeling is mutual.
Okay, so have a fine day. Bye-bye.